All right, welcome back, everyone. Happy New Year. We're going to talk about negative exponents this week. And negative exponents are something that have been a little bit confusing in the past, but hopefully we can make it something that you can understand pretty easily. And the key to remembering how to deal with negative exponents is that the negative exponents or the negative power is telling us to move the base. All right, so mathematically, there's a much more complex explanation. It involves the term multiplicative inverse being raised to the opposite power, positive opposite power. And that's all complex. And so there's a really easy way to think about it. And if we just look at this first one, and if we see something like 3 to the negative 2 power, we simply take that 3 to the negative 2 power and turn it into a fraction. So we turn it into 1/3. But then we keep the power with the 3, but we change it to positive. So 3 to the negative 2 becomes 1 over 3 to the second power. So essentially what happened is we had a fraction, and the 3 to the negative 2 just moved to the bottom, or moved to the denominator, and the negative 2 became positive. Okay, so that's essentially what we're going to be doing. We're just going to be taking something that's in the numerator and moving it to the denominator if we have a negative power. And then likewise, we'll get into some examples in a bit where if it starts in the denominator and it has a negative power, it needs to move up to the numerator. But the key thing is it only applies to whatever the exponent is on. So in this next example, we have 2x to the negative third power. The 2 is not influenced by the negative third power. So the 2 is going to stay exactly where it is. It's going to stay in the numerator, but the x is going to move to the denominator, and the power is going to change to positive. So we're going to end up with 2 over x to the third power. So the only thing that moved is the x to the negative third power. It moved to the denominator and became positive. Okay, we can do some simple addition problems, but before we can do addition here, what we want to do is deal with these exponents first. So 2 to the negative 1 power, 4 to the negative 1 power. So the 2 is going to move to a denominator. The 4 is going to move to a denominator. They're going to be separate fractions. So we're going to have 1 over 2. And we don't even put the power of 1 there. We can, I guess, if you want, but it's just going to kind of get in the way. So we just kind of need to remember, hey, if something has a power of 1, it's just the number itself. So we can just leave it as a 2. And then the second fraction will be 1 over 4. And then we just want to go ahead and add those two together. And well, 1/2 plus 1/4, that's 3/4. All right, and then another couple of examples here. Negative 2 to the negative fourth power. A lot of times what people do here is they see the negative 2 and they think that that's going to change in some way. The base is not going to change other than it's going to move. So in every example up until now, the base just moved where it was from the numerator to the denominator. And in this case, the same thing is going to happen. We're just going to move that base of negative 2 to the denominator, but we're going to change the exponent to positive. Okay, and then this one, since it's negative 2 to the fourth power, we can simplify that. And if you remember, any negative number to a even power is going to end up being positive. So we have negative 2 times negative 2 is 4, times negative 2 is negative 8, and then times negative 2 is positive 16. So it becomes 1 over 16, actually. Okay, and then the last one here, y to the negative fourth power. Again, anytime we take something to a negative power, it's telling us to move that base. So the base is going to move to the denominator, and it's going to become positive 4. All right, and I mentioned it earlier. If we have something that has a negative power in the denominator, it's simply going to move from the denominator to the numerator. And well, right now there's a 1 in the numerator already, and we don't really have to worry about that 1 because it's just 1. And when we move that x to the third up to the numerator, we end up with 1 times x to the third, which is just x to the third. Okay, so anytime there's a 1 there in the numerator, we can kind of ignore it because it's just multiplying by the x to the third. But notice the x to the negative third moved to the numerator and became x to the positive third. Okay, similarly with a number to a negative power, it's going to be 1 times 3, but we can just ignore that. It just becomes 3 to the 4th power. And this one we can simplify. So 3 times 3 is 9, times 3 is 27, times 3 is 81. So some of these we're going to start to remember. 3 to the 4th power, 3 to the 3rd power, so on. 2 to the 3rd power, 4th power, 5th power, and so on. Which we should start to memorize those, so we can do those pretty quickly without having to turn to a calculator. Okay, so negative. Now, what happens if we combine and we have a negative exponent in the numerator and in the denominator? Well, we're going to apply the same rule, and whatever's negative in the numerator moves to the denominator. Whatever is negative in the denominator moves to the numerator. So in this case, we're going to have q. That's a q. It's kind of a funny looking letter. Q to the 9th power. So the negative 9 becomes positive 9. It's up in the numerator now. And then p to the negative 4th becomes p to the 4th in the denominator. Okay, so the q went to the top, the p came down to the bottom. All right, similarly with this last one, the 5 is going to move to the denominator, the 2 is going to move to the numerator, so we have 2 to the 5th power up on top in the numerator, and then 5 to the 3rd power in the denominator. Okay, and in this one we can simplify a little bit. So 2 to the 5th power, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, so this is 32. And then 5 to the 3rd power is 5 times 5 is 25, times 5 is 125. So we could simplify that into a fraction that looks like that. All right. Let's see. Oh, here we go. All right, so some of these now add a little extra step. So here we have something other than a 1 in the numerator, and we're going to move this y to the negative 2 up to the numerator. So this is going to become, so the y in the numerator stays, so that one stays, but then we move that y to the negative 2 up top, and it becomes positive 2, and we have to multiply those together when we move it up to the top. Okay, just like we did with the 1 in that first example, in the second set of examples, that 1 was there, so I had to multiply it by the 1, but we eventually can just ignore that 1 and pretend like it's not there. But when we have something there that's not a 1, like a y in this case, we have to actually multiply. So now we have y to the 1 times y squared, so this ends up being y to the 3rd. Okay, so similarly, in example B here, the x to the negative 4th is going to move to the numerator, and it becomes positive, so it's 3x to the 4th. Okay, and then in the next one, now if you remember from the previous examples up above, these two things just switch places and the signs change to positive. So that's another way to kind of think about it to make things go more quickly is, hey, I'm just going to flip this over. I'm just going to put the y on top, the x on the bottom, but then I just keep the exponent but change it to positive in both cases. Okay, and then with this one, there's a couple of different ways we can look at this. We could apply the power rule first if we wanted to. If we apply the power rule, this becomes 2 to the negative 3rd over 3 to the negative 3rd. And then those two things are going to switch places because they have negative exponents, so it becomes 3 to the 3rd over 2 to the 3rd. And then we can simplify that, so it becomes 27 over 8. Okay, another way to look at it is when I have something in parentheses like this, well, what happened? The 3 and the 2 switched places and the exponent became positive, right? So if you look here, the 3 and the 2 switched places, the exponent became positive. So what we could do, instead of applying the power rule, is we could just say, hey, I'm going to apply the negative exponent rule. I'm going to flip this over and then change the exponent to a positive 3. And now I can apply the power rule, and it's 3 to the 3rd over 2 to the 3rd. So there's two different ways we can approach this one. And it really depends on you whether or not you like to do it the first way I did it or the second way. It doesn't matter. You end up with the same answer, which is 27/8. All right, that's it. So you got an assignment here. So this is the basics of negative exponents. In the next assignment that we're going to do this week, we're going to take this a little bit further and have much more complex things that we're applying the negative exponent rule to.